a little bit about location and location-based services. Uh, Location is not something that is new. It's not come with Wi-Fi or any wireless technology. This has been around for a long time. And the kind of issues we try to solve with location, probably all of you know, is things like you need to find out where you are. You're lost. You need to find your way to where you're going. Whatever. That's like a personal location sort of solution that you need. As a business, also there are a lot of needs to have location information. Things like how many people are coming into my store. I have a marketing campaign, and is that marketing campaign working because I've got more footfall than I had when the marketing campaign was not on? Or if you look at things like how many people spend time in my store, how long do they spend time? If I'm a quick service restaurant, how many people stay in my restaurant for how long, and do I have more rush during dinner or during lunch? So whole sort of requirements are there from a business perspective. And obviously for a very long time there has been a need for asset management. So even before Wi-Fi and wireless technologies were around, there were a lot of technologies that used to give you information about where are my assets. If you want to find a specific asset, especially in places where there are very sort of expensive assets or critical assets. For example, you are in a hospital, and if you've got like 2 defibrillators, you need to know where they are at any given time because you don't know when you will need them. So these are the kind of solutions that are required in the market from a location-based perspective. And as Wi-Fi became common, people started saying, look, I'm going to deploy all of these access points all over my place, and I already have this infrastructure with me. Can I use the same infrastructure to also do location? And that's why location-based services became very, very common when Wi-Fi started getting deployed as a basic infrastructure in businesses, at home. And as you start having devices that had wireless capabilities, suddenly people said, okay, this is a very good match that we need to put location with all of these technologies that are coming up. We can use this, leverage this. So that's where it came in from. Going a little bit into what are the different applications, you can broadly classify the applications that are there in location into 3 buckets, right? The first one is the consumer. As I have a device in my hand, I need to know about where I am, where am I going, find my friend because we decided to meet somewhere, and now I don't know where that friend is because either he or I are lost. It's just applications that I need from a location perspective. And then there is all this business kind of applications that we talked about in terms of analytics, in terms of asset management, in terms of being able to gather information about what location is working, what location is not working, when is what location working, all sorts of that. And then there is a huge requirement of this from a safety perspective. So basically, for first responders, like when you make a 911 call, or in like Europe it is called 122, E122. So tracking your child, lone worker, which is a huge thing when people go into mines, etc. If they're working alone, people need to know where they are. So a lot of these applications are there, and as I said, this is not new. Like even when Wi-Fi was not there, people used to use things like RFID or some other technologies to actually get these locations. So, but with Wi-Fi, these things have been sort of moving pretty into the mainstream, and you see that almost every Wi-Fi vendor gives you some kind of a solution into the location space. Broadly classifying, there are actually very, very broadly 2 use cases, right? One is where the device knows where it is, and then it enables solutions based on that, right? Because now you're equating a device to a person. So now you're having personal location solutions. That is one. That's when the device knows where it is, and then it sort of tries to give you some information about how to get to some other place, or things like that. And then there is a use case where the infrastructure needs to know where devices are, right? And that is sort of something that actually gives you all the business kind of benefits that we talked about earlier. So very broadly speaking, these are the 2 kind of use cases. And if you see, the first use case is where the device players actually come in, right? That is where the Android and iOS and all of these sort of operating systems on the device give you tools to use location that are available on the devices and then give you some information out of it. And then the other one is where the infrastructure actually collects information about devices and then sort of gives you, sort of solutions around it. So these are the broadly two kind of classifications where you would see different use cases. And broadly, all of the other sort of applications that I talked about in this slide can be classified into one of these two applications. And these, as you see, is very different from each other. One is a client-side application. The other is an infrastructure-side application. And different technologies have been used for doing this. Like, GPS is one of the very common used technology on the client side, where it uses the GPS satellites to derive. And then there are sort of ways to enhance your GPS location. But that's what's used on the client side. On the infrastructure side, you used to have RFID, and now you have Wi-Fi beacons, and you kind of have Wi-Fi triangulation, and so many other things that are coming up. So that's where this is. So the key differences is that client side is usually fast. You just need the information for that one client. Once you get that information, you just need to superposition that information on some sort of a GIS information or a floor map, and you're done. But when it comes to the infrastructure side, there will be a large volume. If you're doing asset management, then you've got like 5,000 devices. You need to know where they are, or at least on demand, you should be able to find out where any one of those devices is. So there's a lot of volume that goes on. It needs computing resources, which means that going out of the cloud is probably a good way to kind of do it. And then GIS and other sort of floor maps, etc., are readily available because people set it up before it sort of rolls out. So those are the two broad use cases. And what I did was I very quickly tried to see if I can do a quick comparison between the technologies that are broadly used nowadays. And I'm going to focus only on technologies that make sense for a Wi-Fi or a wireless infrastructure that rolls out into the enterprise. There is also LTE and other places where location work is being done, which is somewhat similar, but the focus is going to be on Wi-Fi and related technologies. So first one is signal triangulation, right? This is like a very commonly used technology. You can get signal information from 4 or 5 devices whose location you know, and then you can find out what your own location is. Or if given a device, if the infrastructure knows that here are the other 5 or 6 receivers who are seeing a signal from this device, it can actually find out where that device is by using triangulation methods. And then one of the challenges of this is that it's noisy, and radio signal is stationary but not static, which means that every packet will have a different RSSI because of different. So it needs sort of smoothing out and some sort of site surveys and some sort of environmental information is required. And environmental information changes, right? In a room you didn't have a filing cabinet, now you have a filing cabinet, and then your sort of RF environment has changed. Signal properties will change. So you need constant calibration is required. And then it also depends upon the TX power of the transmitter. If you have devices which are handheld or laptops or other Wi-Fi beacons, different vendors would put different transmit powers to save power or for other needs. And then this location will depend upon the TX power of the device. The other very commonly used technology today is a BLE beacon, which is also called iBeacons. And the BLE beacons are actually very good when you're looking at a client-side application. When a device needs to know where it is, it's very easy because you are going to sprinkle these beacons in an environment, and your client can actually see the beacons and then talks to some service which tells them, okay, this beacon is here, so you are also here. So it's a fairly fast location. It doesn't try to be very, very very accurate. There are though people use BLE beacons and do signal triangulation, but that falls into the signal triangulation bucket. But if just a BLE beacon is just proximity based. But the bigger challenge here is to actually deploy these beacons. If you really want good accuracy, you need so many beacons, right? And there have been use cases where people have put like, maybe like like 50 beacons in a store, or just a huge amount of beacons. And now you need to start managing these beacons. Each beacon has an ID that's either built in or you can set it up. But now you have to start giving location information to every beacon, which the client can then download or get back. So the beacon management is a challenge in the BLE beacon side. And also one of the other things which I have not probably, I've actually mentioned here is that obviously this requires an app. So when your client sees a beacon, it needs to know where to go and do what with this beacon, right? So there has to be an app on your application, on your phone, on the device, which does something about the visibility of this beacon. And this is a challenge now because there is this concept that's coming up, which is called app fatigue. People don't want too many apps on their phone, right? You kind of, earlier, apps were a cool thing. You downloaded apps, you kind of started installing it, but now people are trying to move away from the apps. And Apple did something to sort of create an iBeacon stack and then give notifications based on that, but that's limited to 16 beacons. So if you have more applications, then it becomes a problem. So these are the two very commonly used technologies out there. Another technology that actually came up, and this was ratified in 2015, if I'm not wrong, was 11MC, which actually measured the round trip time. So there was a specific frame that the AP sent, which the which the client sent, and the AP would actually respond back. And depending upon how much time it took for the frame to come back, it will give you the time of flight. And then you could determine how far away you are from the AP. And if you had 2 or 3 APs, you could probably get much better in terms of where your location is. Now, this actually, and I've said here, this is like in the combined mode, which means that both the device which needs to find its location and the device that's assisting it, both need to have the support for this. Only then it works. It's not like a single thing. For example, if you look at the signal triangulation, the device that you're trying to locate, it doesn't need any support. All you need to see is frames coming out of that particular device and what is the signal strength of the device. But here you need support from both sides. And non-line of sight signals can actually confuse this 11MC in a way. So, and then given that now we are getting into multiple streams and things which actually require you to have multipath, which will probably confuse this even further. There is another technology which is called angle of arrival. And what it does very quickly, to kind of explain to you, is that you have a receiver that has multiple antennas, and there is a level of orthogonality on those antennas, which means when you get a signal, if you look at the phase difference between these antennas, right, you can figure out in which direction this signal actually came from. And if you knew if your signal is coming from a particular angle to some frame of reference, and if you know this from 3, 4, 5 different transmitters, you can actually figure out as to where you are when you sort of plot this graph. You can actually find out where you are. Now, this obviously requires specialized antennas, and it also requires some sort of logic to actually figure out where you are and how you are oriented in space, because rotating this will also have a little bit of a difference in where you would see the angle coming from. So this requires some specialized hardware. Again, non-line of sight signals will create issues with this particular technology, but this is there. This is something that is being worked on pretty, I know that there's work going on this, and this was supposed to be out with BLE Spec 5, which came out in November last year, but it didn't make it to that spec, and we are expecting that BLE 5.1 will actually have this as a part of the spec. And Shrikant, you may know what is the time frame for BLE 5.1, but that's when this is expected to be out. Actually, Marvell has a chip already which supports this. So it has a SoC that has 802.11 AC, 11P, and it has BLE 5, and it also has this. And there is a company in Finland, I forget the name, which actually has devices where both the sort of locator and tag you can buy from them, and it can actually do this based on angle of arrival. But this is something that's not really ready right now for prime time, because there isn't too much support for it yet. And then there is time difference of arrival. This is what GPS uses, but in theory, you could do it on Wi-Fi as well. The bigger challenge here really is that it requires timing synchronization, very fine timing synchronization between the transmitters from where you get the signal, right? GPS does it using atomic clocks, but how will we do this on the APs is a challenge. But this is something that, given the development in technology that will happen, this is something that is not something that is far-fetched. We can see this sooner rather than later. And I guess this will come in, sometime. But here again, line of sight is required. That is one of the requirements for this particular technology. But this is actually fairly accurate. There is already a lot of devices that uses this because GPS is based out of this. So there is already work that has been done on this. So it might be easier to deploy this once we figure out how to synchronize the time across the transmitters from which you're going to get the signal. So the current options really for a vendor like Mojo to give you some solutions around. These are primarily the two things that we have, right? The signal triangulation and BLE beacons. So just trying to kind of get the pros and cons of these two things out there, right? Signal triangulation is a mature solution. A lot of work has been done. People have written algorithms to make it more and more accurate. Automatic calibration and things like that have been brought into the picture. Fingerprinting of locations, etc., has been done. Even Mojo has a way in which, once you drop the APs onto the floor map, we do auto calibration and based on the signals that are seen from one AP by other APs and things like that. So a lot of work has been done. It's fairly mature, and there are multiple solutions available. Like vendors like Mojo obviously give you a built-in solution when you buy a solution, but then there are solutions out there which just take RSSI information, and Wi-Fi vendors can actually export this RSI information to them, and they would run a location engine and give you location information. 11K and 11V also did a lot of measurements which actually come back from these protocols, and you could probably use that to make this even better in terms of how this triangulation is done. And as I said, there are implementations where BLE beacons are used to do signal triangulation because you know the signal strength of the BLE beacon that you're seeing. So you could actually use the BLE beacons themselves to do signal triangulation. And the cons really is that accuracy is still poor, right? A lot of work is happening, a lot of things we are doing, but still we find that there are, accuracy is not where you want, right? I have heard about people asking for, sub-meter accuracy. That is what people ask for, and I sometimes, as a product manager, question the client as to why do you need a sub-meter accuracy, but that's what people ask for. And we're not close to getting there with this signal triangulation yet. And then, it needs repeated calibration, as I said, because RF environment changes. And then BLE beacons is that the pro is while it is really newer, there's very good adoption for it. And really, the kind of credit goes to Apple because it came up with iBeacons, and now every new phone will have support for BLE. BLE beacons are available, cheap, last for 5 years, battery-based. You can just throw them wherever you want. But management of these beacons continues to remain a challenge as to how are you going to manage these beacons. And you need a very high density of beacon. And one of the challenges that we face as an AP vendor is that even though we can put a BLE beacon inside every AP, if you really want to do good location with BLEs, you need more density of beacons than you have number of APs. So just having a beacon inside an AP doesn't really help, which is what there's this huge fad of people saying, okay, I'll put BLEs in the AP, I'm going to deploy APs, and so I'll have BLE. But you need more beacons than you need APs. So that's a challenge today. And then obviously you need specialized apps and you need specialized backends to be able to take advantage of these beacons. So signal and triangulation is good when you want approximate location of any Wi-Fi device. Is it in this cube or not? Is it in this small room or not? Yes, this is a very good solution for that. BLE beacons are good when you want to find out the proximity of a handle. Am I next to an art exhibit that I'm looking at, and then can an application give me information about that art exhibit? And if there's a BLE beacon connected to that art installation, I can get that information. So applications like this, or in a store, you're in an aisle and there's a beacon in the aisle, you can find out what's there on the aisle, what are the deals that are there on the aisle. You can be pushed coupons for items that are in the aisle. So those kind of applications, BLE beacon is great, right? And then, but then with signal triangulation, if you want to do real-time application of multiple devices like asset management in real time, a lot of data needs to be churned out, a lot of processing power is required. So that's a challenge there. And then, beacons, major minor ID management, all that we already talked about it. That's the kind of challenge out there. So what about 802.11MC? What's happening with 802.11MC? And this is something that, is that there was a lot of kind of enthusiasm about it in 2015. Actually, Intel did a live demonstration of this in MWC 2015. They actually showed like a sub-meter kind of accuracy on a guy holding a device. There's also a video if you go to the Intel site, which actually shows you this. The location accuracy design target here is less than 3 meters, and you can really achieve this. This is fairly good, but I haven't seen real sort of enthusiasm from the chip vendors, and I don't know why that is, but not too much work is being done. Qualcomm has the hooks for 11MC, but Gopi probably knows that there are challenges to try and get that to work, right? So I have not seen enough enthusiasm from the chip vendors to make sure that MC works. And I don't know if it's the quality of the timing that is required or the accuracy of the timing that is required, something, but I have not seen why chipsets don't want to do this. And what about angle of arrival and time? Yeah, this is the last slide. So as I said, for angle of arrival, Marvell already has a chip that is available today to purchase. It's in production, which will do this. And then it is supposed to be expected as a spec with the BLE 5.1. I don't have the date around which this is expected, but it should be expected in a month or two. But once that happens, you will see more support for it on the BLE chipsets that are coming out. And then time difference of arrival, as I said, it requires accurate synchronization between transmitters. And this is a challenge, and if we can find this challenge, then, but then I'm not sure if any work is happening either from the Wi-Fi side or the BLE side. But I believe this is a promising thing that, we can get into to get really accurate sort of locationing. So that's all I had for you today. And if there are any questions, do we have any time?
Yeah, we have time for sets up for the next, I think, yeah, go ahead. Anybody has a question? Yeah, Vignesh? I think you just shout it out and then maybe Jatin can just reply.
Yes.
Why can't we use it for the location update here?
Right. So if you look at massive MIMOs, or if you look at, if I go
the
to
beamforming.
yeah. So if you look at, so basically what you're talking about are having multiple transmitters or receivers which are orthogonal, and hence you get multiple streams. So the angle of arrival is actually a technology that actually makes use of that. One of the key sort of things with massive MIMOs or even regular MIMO with 11AC wave 2 or even wave 1 is that it depends upon multiple spatial streams, which means that you're looking at reflections and other things which are not non-line of sight. And once you have signals which are non-line of sight, then the kind of phase difference that you will get at the receivers, if you have got, let's say, 5 antennas inside a receiver, and the phase difference that you get on receivers, you can actually, so what you're doing is you're actually using that orthogonality to increase the bit rate, right, by making sure that you take care of this orthogonality and you can have multiple spatial streams coming into your antennas. But as soon as you're going to have multiple spatial streams which are not line of sight, right, and multiple spatial streams will never be line of sight only. So what will happen is that the angle of arrival is actually going to be different, and that is what confuses these algorithms. So it's a challenge to use it from that perspective.
We can still take some questions. Still, Akash is ready. Yeah.
That's quota. Okay.
The location can be estimated within meters, 10 meters, and centimeters, and so on, which you already covered.
Good afternoon, honorable members of the jury, ladies and gentlemen.
10 meters
I'm
might
Sagar
be enough
Satpathy
for
from NIT Rourkela,
location-based
presenting my
services
idea
and so on.
for the
I mean,
Wi-Fi.
under 1 meter is, I mean, you're right in questioning who needs it. Right? So why is that people are still asking for the, under 1 meter?
So,
And
so no, let me tell you what happens with these customers, right? One of one of the very prominent sort of Wi-Fi vendors, actually like 2 years back in one of the sort of yearly sort of Wi-Fi sort of conferences, they showed a map where you can actually see a person moving in real time. Now, while it's good, but if you want to do this for every person inside your office or whatever, it's hard. It's hard to do it at a large scale or a scale which makes sense to an enterprise. But given that we are showing people this kind of things also raises expectations. Now, see what happens is that if you look at, let's say if I take an example of a hospital, and there is a very critical piece of equipment which is required wherever it's expensive, so the hospital can't buy one for every room. But if it needs to locate this very quickly, just saying it is in OT1 may not be good enough. You want to know that it is in this cabinet in OT1, right? Because of, so there are valid use cases where people want, but a general enterprise kind of a use case, I don't see why people need a sub-meter accuracy, right? So for example, we kind of work with a lot of fast food restaurants. All they really need to know is inside or out, and how long they are there, because they just need to know how many people are coming during lunchtime, how long do they spend their time, can I get them to move out faster because people outside can come in, right? So for them, just inside to outside might be good enough. So really this depends upon applications, and I'm not saying that there are no applications that require a sub 3 meter kind of accuracy. There are very less of those, and those are the kind of customers who can really pay for expensive equipment or pay for technologies like angle of arrival, which is still evolving, but which will give you very good accuracy, right? So there are use cases in both cases, but generally people ask for it because they've seen it somewhere. They know that people claim that they can do it, and we, as Mojo, we also claim to be doing like sub 10 meter accuracy, right, or even sub 5 meter accuracy, and we do it in most cases. But I think it's us to actually set the expectation of the customers. As a product manager, I've seen that a lot of time you go to a customer, they don't really know what they need, right? They are, they have information from a lot of vendors, and they're trying to get the best out of all of those. So it's for us to also, as product managers, I don't know how many product managers are here, but it's for us to also set the sort of expectations from, we are the ones who really set these expectations.
The non-line of sight having problem with multi-streams, but you can always force the client to do a single stream for this purpose and still do the measurements and actually force it on, right?
Yeah, so which means that now you need client-side cooperation. See, one of the bigger challenges that we have is, as an infrastructure vendor, how can I get location of different devices that are out there, right? If I have client cooperation, yes, I can do a lot of things.
No, you need not
right?
have a client cooperation, but just force the client, so you advertise only single stream capability, the client is going to come back with a single stream
but then
package
what happens
for,
is that,
for a short duration of time.
So what happens is that then I have to start doing scheduling as to when I'm going to do that. Yes. Will it affect the throughput of the client? Will it affect application experience from the client? So it gets a lot more messy. If I can get into a situation where I don't need any client cooperation, if I can get into that situation, that is best, right? One of the key sort of goals that people have put onto us is to say, can you get me a sub-meter accuracy without putting any additional resources either on the API or the client, right? So those are the kind of challenges that we're facing. So yes, you can do that. The point is that if you don't expect cooperation from the client, you can actually give a much cheaper, better solution, which works in all cases, because there might be clients who do not comply with your request. We've seen that clients sometimes, just do what they want to do, right? And Wi-Fi really, that is the case where, sometimes this client doesn't, cooperate with you from that matter. So if you have a cooperating client, yes, you can do a lot.